isn't it? Cerebrospinal fluid is fluid that's been derived from the blood. So in this case, much of what cerebrospinal fluid contains, the blood also contains, yes? And with respect to the concentration of cerebrospinal, it's directly influenced by the concentration of the blood which formed it. And so, the more concentrated your body fluids, your blood, the more concentrated will be your cerebrospinal fluid. As cerebrospinal fluid gets concentrated thicker, the cells in the hypothalamus, these specialized cells known as osmoreceptors, respond to the increased concentration of body fluids by losing water. And as they lose water, the cells tend to shrivel up. As the osmoreceptors react to the increased concentration of body fluids by crenating, wrinkling their cell membranes. As they shrivel up, I use the example of a dried out grape is a raisin, yes? Mm-hmm. And you know the skin of a raisin is all wrinkled, yes? Because it's lost its fluid. Mm-hmm. As the osmoreceptors shrivel up, they're nerve cells, so they get active. The osmoreceptors send a nervous impulse down to the posterior pituitary and call for the release of ADH into the bloodstream. ADH circulates in the blood, and when it arrives at the kidney, the cell membranes of cells that form the distal convoluted tubule, and the cell membranes that form that portion of the collecting duct, which hasn't entered the pyramid just yet, that is still out there in the cortex, those cell membranes have specialized receptors which respond to ADH. And when ADH lands on the surface of these two cells at their receptor sites, we see them increase their porosity or permeability. ADH increases the cells of the distal convoluted tubule and cortical collecting duct to water. Water will leak out of the distal convoluted tubule. Water will leak out of the cortical portion of the collecting duct and be reabsorbed into the peritubular capillaries. Moving the water back into the bloodstream represents the body's attempt to retain, hold water, not lose it in the urine, yes? This direct effect that the hormone has on the distal convoluted tubule and collecting duct, this process is known as facultative water reabsorption because there's no intermediates required. I say that because we then discussed aldosterone, another water-regulating hormone whose method of action involved sodium retention. And if you reabsorb sodium, you're going to reabsorb chloride. That's a salt. Wherever the salt goes, the water is bound to follow. So by reabsorbing sodium, i.e. sodium chloride, we obligate water to move with the sodium. So that kind of water reabsorption is called obligatory. It's indirect. You're reabsorbing sodium and then water, yes? This is direct and immediate. It's directly water reabsorption we're talking about. Yes? Does that help you? Anybody else?